So chapter 9.3, this is where things get a little bit more, I guess, relative to you guys, because, in maybe just a couple of years, you guys will be thinking about buying a house or something along those lines and having to pay a mortgage and whatnot. So it's good to know kind of how you can figure out what you can afford, um, and, how to go about that process of seeing what's the most you can afford a house for, what sort of interest rate would you look to get, things like that. So amortization. Oops, dropped my pen. Amortization, a consumer who makes a purchase but does not have the funds to pay cash for it in one way or another must take out a loan from the seller or from a third party. So for example, I went out and I bought a new quote unquote car, um, and the dealership that was selling it offered their own, I guess, loan, if you will, right? Their own loan, so they'll own the car and they'll charge me a monthly amount with a certain interest rate to pay off that loan for the car. And once I pay off the loan for the car, then the car becomes mine. Or I could go to my bank and I can tell my bank what the car costs, and they can offer me a different loan, maybe at a different interest rate, and so on. So, you can get a loan from either the dealership who's selling the car or from your bank. Or there's other loan companies out there that you can look at as well. But there's more than one option, which is what I want to emphasize to you. You should go out and you should do your homework, do your research as to where you might get the best deal for your loan. My bank gave me a much better deal than the dealership, so it's worth going around and exploring those options. So it is common for both the principal and the interest of such a loan to be repaid by making a sequence of equal payments at regular intervals, usually monthly. In such a case, the loan is said to be amortized. So amortization is essentially what you guys have all probably thought of before when you take a loan out, when you buy something, the process of paying that back. When you're paying back a loan, you're paying not only part of the loan back every month, but you're also paying part of the interest the loan's accumulating every month. So in a way, you're paying both principal and interest over time. Now, if you buy a house, just a heads up, if you buy a house, the first several years of paying back your house, let's say you buy a house for, I don't know, $200,000, of course, with a loan, the first couple of years of all the money you spend on your mortgage paying back to the bank, most of that money is just paying off the interest that is accumulating from that $200,000 loan. You don't actually start to pay off the principal of, that original. You don't really start paying off the $200,000 or making a big dent into paying off the $200,000 until several years after you've bought the house, which is why some people suggest renting as a better option for a short-term outlook. So if you plan on moving in a year, there's no reason to buy a house. It's probably better that you rent, because if you buy a house, you're going to probably be paying back more in just interest than you would in the equity of the house. Anyway, there's a whole lot you can talk about with that, but let's just talk about the math behind it. So amortization payments, this is for those loan payments. This is for like your mortgages or your car loans. Okay. So here's our formula. Y is going to represent our payments amount. So Y is going to be like our monthly payment. Typically monthly. It doesn't have to be monthly, but most of the time mortgages, car loans, things like that are monthly. K, of course, and N represent the same thing they've been representing, which is our interest rate and our number of time periods being compounded. L is going to be our loan amount in this case. So there's our formula. We're going to be using it in these upcoming examples. So example 1, the cash price for a 2-year-old car is $8,000. If the total amount is to be paid by monthly payments, and if interest is 75% per month, or not 75%, 0.75% per month, what monthly payments will pay off the loan in 36 months? And basically we're solving two problems, in 36 months and in 48 months. We're going to look at both we're going to basically do this problem twice, once for each of those time periods. So go back to our formula, right? Let's make sure we note this and have it written down. So I'm going to write that formula down. We got y equals KL over 1 minus 1 plus K to the negative n power. Now, if you really want to know how that formula is derived, be my guest to go through Google. I'm not going to spend the half hour to try and tell you just where that formula comes from. But if it does interest you, I'll let you go ahead and do your own research on that. You can call it the amortization payment formula. So if you really want to go all in and figuring out why it is what it is. All right, so first off, our y is going to be our payment amount, which is what we're looking for. K, remember, is our interest rate per unit of time. So we are paying 0.75% interest, but that 0.75 is really not even 0.75 because that's 0.75%, right? So as a percent, you still need to move that decimal. So it's really going to be 0.0075. And not even that. Well, is it that? Hold on. Yeah. I suppose it is. No. Take it back. If it's 0.075, but it's monthly, it's going to have to be divided by 12, no? I'm trying to look at this in the textbook and determine whether they've done it right or not. Right, well, we're going to go with it. 0.0075 times our loan amount, which is $8,000, divided by 1 minus 1 plus K, which is 0.0075, to the negative n power, and it's 36 months. Okay. All right, now I get why you're not taking your K value, which is the 0.075, and dividing it by 12 like we've done in the past. The reason why is because it says that this interest rate is per month, not per year. If it was per month, or I'm sorry, if it was per year, but then compounded per month, we would divide it by 12 to get the per month percentage. But it's already telling us directly that it is the per month percentage. So technically, whatever the yearly is, they've already done it and divided it by 12. So we have our actual per month percent. So that's the reason why we keep it, as the 0.075. We don't have to divide it by 12 because in theory that's already been done for us, because it does say that this is the interest rate per month, not per year. Okay, and we know that the end value is 36, at least for the 36-month loan, because that's how many times it's compounded every month. 36 months would mean it's compounded 36 times. So if we go back and we type this into our calculator, so I would type it in like this. I would hit alpha y equals to get my fraction bar, right? And so 0.0075 times 8,000. We can put that in parentheses. That'll be fine. I'm going to, just like I wrote it, I suppose. 8,000, close parentheses, divided by 1 minus, put parentheses on this, 1 plus 0.0075. Oops. Close parenthesis, and then to the n power, which is negative. Keep in mind that there's a negative in our formula. It's kind of weird, but nevertheless, it is there. So that gives us $254.40. $254 and change, 40 cents. So that would be our monthly payment if we went for a 36-month loan. Now, if we go for a 48-month loan, we would just change that to a minus 48. Everything else stays the same. The interest rate still stays the same. The loan amount still stays the same. So we can just go back and we could just type that in one more time, but just change it to 48. And the monthly payment would be $199.08. So, of course, if the loan is for a longer period of time, then you're paying off a smaller amount each month. So the monthly payment is a little bit shorter. I think most car loans probably go for about 60 months. Obviously, if you're doing like a mortgage, that's like 15 years or 30 years most commonly. But for car loans, it's usually about 5 years or 60 months or so. But anyway, there it is. Just be very aware, I think, of the per month thing. That was kind of confusing for a moment, but we handled it pretty well. Example 2. The Young family plans to purchase a new house. One house in which they are interested would require them to take a $60,000 mortgage. They can obtain a mortgage for 25 years at an interest rate of 8.4%. Find the monthly payment. Same formula as last time. So it's our monthly payment Y will equal our interest rate K times our loan amount divided by 1 minus 1 plus K to the negative n power. So let's start filling in the gaps here. K will be our interest rate, right? So our interest rate is 8.4%. Now, it doesn't specify that this is annual interest rate, so we're going to assume it's the annual interest rate, and that 0.084 will need to be divided by 12 so that we can get the monthly interest rate, because 8.4% is our annual interest rate. But if we're doing monthly payments, we need to know, and this interest rate being compounded every month, we need to divide it by 12 to get the interest rate per month. And that value becomes 0.007, so 007. Very cool. All right, so that's our K value. So we have 0.007 times L. L is our loan amount, which we already know. It's obvious. It's $60,000. Divided by 1 minus 1 plus our K value, which is 0.007, to the negative n power. And we're doing this mortgage for 25 years, and we're paying every month. So 12 times 25 is 300. So this will be negative 300 as the exponent. And again, we'll just go straight to typing this into the calculator and getting our results. So alpha y equals, we'll open up the fraction bar so I can make this easier on myself. 0.007 times 60,000. And then go down to the bottom. We'll have 1 minus 1 plus, oops, I hit the enter button too soon. So fix this. Okay. 1 plus 0.007 to the negative 300 power. Believe I've typed that in right. I'm just double checking real quick. Hit enter, and our monthly payment is $479.10 to be rounded. $479.10. Not bad. That's doable, I would think. It depends on, of course, whatever you're looking to buy. I'm looking to buy a house eventually. It's maybe like $200,000 to $225,000, and I'm looking at maybe my monthly payment probably being $800 to $1,000. Maybe we'll see. Depends on how much my down payment is, but I would say that's pretty doable right there. $60,000 mortgage. 8.4% though is pretty high, I will say. I think most loan amounts for a mortgage are about 5%. Let's move on to example 3. So example 3. So based on example 2, the Youngs consider postponing their purchase for a year because they believe that within that time, interest house financing rates will fall below 8%. However, because of inflation, the price of the house will increase, and they will need a loan of $65,000. Find the monthly payments required to amortize a $65,000 loan over a period of 25 years with interest rates at 6.5, 7, 7.5, and 8% per year. So basically, we are going to try to figure out if it's better for the young family to hold off on buying their house, because if they can get a cheaper interest rate or a lower interest rate, then they won't have to pay as much for the house. But that interest rate needs to be low enough, essentially. We need to figure out if it's worth waiting for, or if they should just go ahead and try to buy the house now, even if the interest rate is a little higher. Because if they wait, the price of the house goes up. Even if their interest rate is lower, the increased value of the house might be enough to still not make it really worth waiting on. So we'll do the math, we'll figure that out. So all we're going to do in this problem is essentially the same thing we did in the last problem, but with different k values. So let's start with the k value for 6.5%. Now 6.5% would be 0.065. And if you divide it by 12, because again, we are doing monthly payments, then we'll get the k value for this first problem. So let me try to make this a little bigger. So what is 0.065 divided by 12? Well, I was going to find out, but I need my calculator. 0.065 divided by 12 is, like 0.00542. We'll round it, 0.00542. We'll go a couple places out. All right, so this would be 0.00542 times the 65,000, because that's going to be our new loan amount, divided by 1 minus 1 plus the 0.00542 to the negative 300th power, because again, it's monthly for 25 years, and that would be 300 months. If you just do 25 times 12. So let's calculate that. We'll see what the monthly payment is. And you might think that this is going to take forever because we have to do this 4 times, but all we have to do is change the k value every time, so it should actually be pretty easy to type in our calculator because we don't really have to change very many things. So let's go ahead, alpha y equals, we'll type this in, 0.00542 times 65,000 divided by 1 minus parentheses 1 plus 0.0054, 542 to the negative 300. So that is $439 and some change. I'm just going to keep it at $439 for now. So now we're going to copy and paste this, and we're going to change it from the 6.5 to the 7.0. So 7.0, or 7, essentially, or really just fix 0.07, divided by 12 is going to be 0.00583, 0.00583. So if we change this whole thing to 0.00583, and all I gotta do is just change that in my calculator, we should be good. Should be good. So I'm just gonna go back, edit what I have, 83, 583. Everything stays the same. The loan amount's still the same. The time is still the same. Hit enter. We get $459 and some change. Now we're going to do it for 7.5. So 7.5 would be 0.075 divided by 12. 0.075 divided by 12 is 0.00625. 625. So again, just change that, 625. Just go back to our calculator and get that result as well. If it's helpful to just skip ahead here, you can if you don't really want to watch me type everything in. That's going to be 480. And then the last one for 8%, 0.08 divided by 12 makes 0.00667. Crap. So if we go back and we change this to 667, 667. We type that in our calculator, we should be all right. All right, we get 501. So now let's answer the question. What will be better? Well, the original loan amount was $479, right? If they buy the mortgage now at the 8.4% interest, they'll have to pay $479 a month. So it'll be cheaper for them. It's basically the same thing if they get 7.5%. 7.5% is basically the same amount because 480 is essentially right, same thing as 479. So if the loan amount drops anywhere less than 7.5, 7.4% probably, and anything smaller than that, I would say it's worth waiting because their monthly payment will be less if the interest rate gets, I would say less than 7.5. But if the interest rate goes below 8, but it's only going to be 7.5% or 8%, then it's really not worth waiting for. In fact, if it's 8%, they'd be paying much more per month. So it is a bit of a gamble if they wait, but they're really hoping that if they do wait and the price of the house goes up, that their interest rate can be somewhat less than 7.5%. As long as it is, their monthly payment will be much lower. Example 4. Alice plans to buy a new condo and she has $18,000 for a down payment. Current interest rates are 8.4% for loans up to 80% of the value of the condo financing and 9% for loans between 80 and 90% of the value. Loans are for 20 years. Alice can afford payments of at most $1,000 per month. Find the value of the most expensive condo that Alice can afford. All right. So there's a little bit of math behind this one as well, as you would think. So there's a key phrase here, the fact that $18,000 is a down payment, and we have two different interest rates depending on the value of our financing. 8.4% for loans that are up to 80% of the value, and then 9% for loans that are more than 80 or between 80 and 90% of the value. So the question is, if she's going to pay $18,000 as a down payment, well, $18,000, I'm trying to explain how to say this. It has to be less than, or has to be that has to be 20% the value of the house. Because if that's 20% or more of the value of the house, then there's going to be 80% or less to pay back, which means she would qualify for that 8.4%. But if the $18,000 is not at least 20% of the value of the house, if it's less than 20% of the value of the condo, if it's less than 20% of the value of the condo, then she's going to be paying that 9%. So the question is, $18,000 is 20% of how much? So $18,000 is 20% of how much? And that answer is, I believe, $90,000. But let me do my double checking. 18,000 divided by the 0.2 is 90,000. So what that was, and that's a math problem hidden inside of this. That $90,000 if she buys a condo for $90,000 and she puts $18,000 down, then she has paid 20% of that value of that condo, and she takes a loan out for the other 80%. Now, because the loan is for 80% of the value of the condo, that would require an 8.4% interest. So now how much will that be? So if she buys a condo that's $90,000, pays $18,000 of it now, then she takes a loan out for $72,000 because $90,000 minus the $18,000 down payment is $72,000. So this is how much she put down. This is how much she owes on her loan. So if we use our formula, we'll have our monthly payment is our K. Now K will be 8.4%, but 0.084 divided by 12 is, what was that again? 0.084 divided by 12, 0.007, so that's our K value, times the $72,000 for the rest of the loan, divided by 1 minus 1 plus 0.007. It's 20 years monthly, so 20 times 12 is 240. So that'd be negative 240. All right, so let's type that in the calculator. I feel like there's so much going on with this problem, and there really is. Alpha y equals. All right, it's 0.007, 72,000. One minus parentheses 1 plus 0.007 to the negative 240. All right, and we get $620.28. So, to summarize that problem, we're not done yet either, by the way, but we're done with at least that first half. Alice has $18,000 for her down payment, which means if she buys a condo that's $90,000 or less, she will qualify for that 8.4% loan because the value of the loan will be no more than 80% of the value of her condo. But if she buys a house or a condo that's more than $90,000, her $18,000 down payment will not be 20% of the value of the condo, which means she'll have to pay the 9% interest. Now, if that's the case, okay, we want to know what's the maximum condo price, what's the maximum value of the condo she can afford at that interest rate if she wants to spend no more than $1,000 per month. So let me clear my screen real quick. Oh, actually, I don't think I can. Now that I think about it. Well, if I turn this off, I can. Or if I close that window. I don't know why it didn't ask me to save, but it didn't ask me to save. If it's still there, I'm be mad. Okay. Oh, it's still there, of course. Autosave is on. That sucks. Okay. I'll work around it. We'll be fine. Okay. So to answer the second question here, if she buys a condo that's more than $90,000, she'll have to pay the 9% for the loan because her down payment will not cover at least 20% of that loan. And she'll have to pay back more than 80% of her condo through that loan. But she doesn't want to exceed a monthly payment of $1,000. So what's the highest value for her condo she can look to afford? So $1,000 per month, that is the Y value. Y represents, remember, the monthly payment. So she wants to say, okay, let's say it's $1,000. This is going to be her maxed out monthly payment. She maxes out her monthly payment at $1,000. At 9% for per month, 0.09 divided by 12 makes 0.0075. So the K value would be 0.0075. Now, what we're trying to look for here is this L value. We're trying to figure out what's the value of the condo she can afford if she doesn't want to exceed $1,000 payment. So 1 minus 1 plus 0.0075 to the, we know the time again, it's 20 years. 20 years, 12 months is 240. So now it just becomes a math problem. We need to solve for L. L will tell us, if we can figure out what L is, that's going to be the amount of the condo that she can afford and pay $1,000 per month for. So if we do this, we'll have to take the 1,000. We can multiply both sides by this amount so that it cancels out on the left and it ends up on the right. So we take the $1,000 and we multiply it by this. We'll get, well, let's do the math. So clear this. The $1,000 times the 1 minus, oops, that's the negative sign. 1 minus parentheses 1 plus 0.0075. Close that parenthesis. Take that to the negative 240 power. Didn't mean to put that parenthesis there. Whoops. Oh my gosh. Well, I guess that parenthesis can be there. That's fine. I'll just have to put another one here. There we go. If we take that $1,000 and multiply it by that denominator, we get 833.587. 833.587. But that will equal still this numerator, which is 0.0075 times L. So if we divide both sides by the 0.0075, we'll have L equal 2. And I know it's very messy on my screen, but I apologize for that. Or we're just taking the value we got, and we're going to divide it by the 0.0075, and we get $111,144.95. So that is the price, that is the highest value condo she can afford. Because at that price, her monthly payment will be $1,000, and that's the most she can pay. Anything higher than that, her monthly payment will be more than $1,000. She doesn't want to do that, but she can afford at most that $111,144 condo. It's a very layered problem because we're essentially answering two different questions at the same time here. But I think we did a decent job. All right, sinking funds. Let's do this kind of quickly. So what a sinking fund is, I'll just read it from the book for you. Okay. Frequently, a company or individual recognizes in advance that certain expenses will occur in the future. If the magnitude and timing of the expenses are known or can be estimated, then provision can be made to cover them. A common approach is to make regular deposits into an account in such a way that the deposits together with the interest earned will be enough to cover the expenses. Such an account is called a sinking fund. So, essentially, a company recognizes the fact that they're going to have to buy new equipment or something, for example, right? They're going to need to buy new equipment in 5 years. And they know that the cost of that equipment will be such and such amount of dollars. So they start saving money now. They start putting money into a sinking fund, which is just another account. They put money into the sinking fund. That money earns interest, so that money grows. And by the time 5 years happens, they have enough money in that account to buy that new equipment. So it's basically another type of savings account. So anyway, that's our formula for it. We're going to use it, of course, in these next few examples. So example 5, the treasurer of the International Brand Muffin Company is told that a set of ovens at the company's Mulberry plant will have to be replaced in 3 years. Corporate finance at an estimated cost of $400,000. The treasurer proposes to make semi-annual payments into an account which pays 5% interest compounded semi-annually. Find the amount of each semi-annual deposit so that after 3 years, there will be $400,000 in the account. Obviously for those new ovens. So our formula, let's go back a second. Our formula, why is the thing on the bottom of my screen still? That's weird. Formula is there. So Y is going to be our deposit amount. That's what we're trying to find out. S will be the future value needed. So our payment amount, which we are looking for, is K times S, which is our amount needed. 1 plus K to the N minus 1. So what we know here is we know our interest rate is 5% compounded semi-annually. So 0.05 divided by 2, because it's twice a year, is going to be 0.025. So that's our K value. So we'll have 0.025. S is how much we're going to need. Now we know we're going to need $400,000. So 400,000 over 1 plus K, which again we know is 0.025, to the N power. So it's 3 years, semi-annually, so that'll be 6 times. 3 years, twice a year, means 6 times, and then minus 1. So there it is. Simply plug it in the calculator, and just to save time, I'll go ahead and get the answer for you. The answer for that, I believe, is $62,619.99. So this is how much the company has to put into this account every 6 months. So every 6 months, the company puts $62,619.99 into an account, and that will earn interest over time. And after 3 years, that account will have $400,000 in it, and they can use that $400,000 to buy their new equipment, their new ovens or whatever. All right, and then our last example. The electric company has $1 million in bonds payable in 5 years. The corporation plans to make quarterly payments into a sinking fund at 7.5% corporate finance interest compounded quarterly. How much should be deposited each quarter so that the end will contain, the fund will, I don't know what it's supposed to say. I made a typo there. Will contain $1 million after 5 years. It's pretty much the same problem. And yeah, it's supposed to say fund, by the way. So to set it up, we have Y equals K times S. Now K is 7.5%, so 0.075 divided by quarters, so divided by 4, which makes the K value 0.1875, or I'm sorry, 0.01875. That's our K value, so 0.01875 times 1 million, because that's the desired amount that we're going to need. I'm going to put commas in here so I keep up with how many zeros I need. All right. 1 plus K, which again is 0.01875, to the N power, so 5 years quarterly, that's going to be 5 times 4, which is 20, minus 1. So there it is. Plug it in the calculator, and we get $41,671.48. So that's how much money they need to put in every quarter, so that in 5 years, that account will have $1 million, and they can do whatever they want with it. So that's going to be it. I know it was super duper long, but you got to do what you got to do. I'll see you guys later. Bye.